Here we can see the interface which is for the movement of each servo motor. The first one, from the left to right, is the servo position in the origin part. The second is the one in the origin of the link 2. And the switch is the one controlling our end effector. Its main purpose is to move 90 degrees to decide if we want to ride or not. For programming the forward kinematics, we first have to understand the robot. In this image, you can see that the first reference is positioned with the x-axis to the right and the y-axis to the up direction. This is because the 0 degrees of the servo is in the x-axis. So in order to program, we must take into consideration that the home position will be when the first link is in 90 degrees and the second one is in 100 minus theta degrees, and this will be explained in the next part. The next servo, in the origin 1, was planned according to how it was placed. Taking into consideration the previous part, the angle of this part, as mentioned before, will be 180 degrees minus theta with respect to the origin of point 1. We can explain the program with the interface. In this image, the components will be described from left to right and from top to bottom. The first controllers, which are labeled are the X and Y, are the ones who define the difference from distance from the origin of the robotic arm to the origin of the workspace. The next three are the L1, L2 and L3. These three controllers define in the program the length of the links. For this case, the length of L1 is 70 centimeters, the L2 is 14.7 centimeters and the L3 is 2.5 centimeters according to the difference from the point of the origin 2 to the pen, which is our end effector. The inputs of the program are the controllers labeled as servo 0 and servo 1. When these are moved, we can see physically and in the indicators labeled as X, Y, and Phi the movements of the robot. The three will be explained mathematically in the next image. The last part are the theta 1 and theta 2, which are the angles previously mentioned in the last image. The x-position of the end effector is defined by the summation of the vectors represented as the distances and the angles of each servo as described in the previous images. It is the same with the y-position of the end effector. By adding the positions of a vector, we also have to add the position of the previous angle of the previous link. Another important part is to notice that the summation of all the angles are the phi value, which is the angle between the origin of the end effector. Here we can see our robot working. As we see here, it should be like in this part, in X 0, and in Y also in 0. And here in this part we can see that more or less it's about 0, but it has some kind of difference, but well, we can manage it later. And well, the thetas are also like in the same angle, such as we can see here. Like we can see that the angle is X and Y, and here also is X and Y, but here we have the 180 degrees minus the angle. Here we're having problems with the serial cable, so we have some disturbances. So we will move it to another point, and we will see how accurate is our robot. So here we're diminishing the angle that, as we said, is 180 minus theta, and here we are moving the other angle. So we see the position is more or less like in our image here. We can see that more or less the x-axis is near the 2. It has a little troubles, but it's nearly. And we can see that the y is in 15, almost 16, but this has to be like with the error signal we have here.
So here we will explain what we did with inverse kinematics. So first of all, we can see the formulas that we apply. Here are the formulas. After that, we can see that if we send the robot to 0, 0, it will go. So again, if we send it to 7.5, the robot goes there with no error. There you can see in the program what we're sending. Finally, if it goes to 15, 15, it will go with no trouble.
For the complete program, we used a combination between MATLAB and LabVIEW. There was created a sub-BI with the MATLAB code, which is in charge of first calculating the points over a certain center point of the circle given by the user. The radius of the circle is also given by the user, and this helps the MATLAB function to calculate the distance between the center and the radius of the drawn circle. After knowing the values, the program calculates the position in the x and y axis. In total, there are 360 points calculated with a function 4. But the complete action is run the circle in 364 steps, which include the movement of the pen up and down. The semicircle program is pretty similar to the last one. The difference is that the user can also decide the angle of the diameter line, which means that the figure can be customized not only in dimension but also with the rotation of this one. With the MATLAB code, the difference is that the angle will be added to the points of the semicircle, which will be 180 points, and the other 180 points are used for the drawing of the diameter line, which is calculated taking into consideration. Just as the last figure, the line is also programmed with 360 points, because that is how the for function in the LabVIEW was first programmed. In this part, the user has to give the 2 points with their x and y coordinates, and the program starts calculating the points first by taking the difference between the last one and the first one divided by 360, the number of points, and then multiplied by the point that is being drawn in that moment, starting from 0. The starting point of the line is the first x and y. In the rectangle program, the user can only play with the dimensions of the shape. Each of the points of the figure is drawn in 90 steps. As we could see with these and other shapes, the lines are not delicately defined, because with the program we cannot control the movement of the two servos at the same time. The two servos are moved at different times, and that is why the figure is drawn by many little tiny lines. At last, with the triangle, the user defines the points of each axis, which are the ones called point 1 and point 1 y and x, up to point 3 and point 3 y and x. The program works in the same way as the rectangle and the straight line.